So today's video is looking at ionic bonding. Now, first and foremost, we need to understand that ionic bonding is a chemical change. Okay, so this is where two or more elements react and combine to form a compound. However, you might also be thinking about physical changes, okay, and what's the difference between them? Well, a physical change is reversible first and foremost, okay, and it's very much dependent on the amount of kinetic energy that's stored within those particles. So, for example, the change from a solid to a liquid relies on those particles having a lot of kinetic energy to therefore break those bonds to then allow that change of state. But like we say, they're reversible. Whereas when we're thinking about a chemical change is an actual change within that element to then form a compound. Okay, so why are we learning this? So when we think about different things within the environment, if you like, and our surroundings, the properties that they have are dependent on the bonds that are present. Okay, so for us to have an understanding of how an element's going to react or ways that we can use that element, we need to understand the bonds that are present. Okay, and without those bonds, nothing would exist. Okay, your body and the systems that you have in your body are very much reliant on chemical bonds too. So even though you might think, well, this is just something from chemistry, there's a chemical makeup of your body as well that's also involved here. Okay, so we've got 3 learning objectives today. The first one is to be able to state what an ionic bond is. The second is to describe which elements form ions. And the third is to be able to draw ionic bonding diagrams. Okay, so first and foremost, to be able to have an understanding of bonding, we need to go back through these key questions. Now, these are questions that you would have had a look at in the first chemistry unit that you studied probably at the start of year 9. So it might be worth just pausing the video here, taking 10 minutes to have a go at these questions. Okay. Now, I'm not going to go through every single one of these because that's not really our focus, but what I'm going to do is just pinpoint a couple that we might not have remembered about. Okay, so for example here, how can mixtures be separated? We've got filtration. So if we think about sandy salty water, if we had a conical flask filled up with sandy salty water, to be able to get that sand out first and foremost, I would filter it. Okay, and then to be able to get the salt out of the water and to be separating that salt with the water, we'd use crystallization. So that's where we heat up the water, we evaporate off the water, which then leaves behind the salt. Okay, so that's crystallization. Distillation is where we separate based on boiling points. Okay, so you might remember fractional distillation, for example, when we're separating crude oil, and chromatography. So you might remember where we do the ink samples, okay, to separate off 2 liquids. Okay, another one that I would like to highlight is 8. So state the masses and charges of subatomic particles. Now this question comes up practically every year in the exam, and it's always worth a lot more marks than you think it should be. Okay, so going through and actually memorising that fact and those masses and those charges is going to be really, really helpful to you. Okay. Right, so going back to ionic bonding then. So a good starting point is to have a look at our periodic table. And if you remember, we've got group 1, group 2, okay, group 3, group 4, group 5, group 6, group 7. Okay, we've got this group on the end, which we used to refer to as group 8, but now we think about as group 0. Now, the reason why group 0 is a really special group is because within it are the noble gases, and these noble gases are very, very stable, okay, because they've got a full outer shell. Okay, so they've got 8 electrons on that outer shell, meaning that they're not reactive. Now, if you want to think about it in sort of a more memorable way in some ways, you can kind of think that every other element in the periodic table really, really wants to have that structure because it's noble. We're aspiring to have that structure. Okay, we want to have a full outer shell, and there's a couple of ways that we can do that. So first of all, they can gain electrons. Okay, so for example, if we think about fluorine here, it could gain 1 electron to its outer shell, and therefore it'd have that noble gas structure. Okay, another way is that they can lose electrons. So if we think about lithium over here, that can lose 1 electron and have a full outer shell, making it more stable. Okay, and another way is that they can share. Now that's covalent bonding, so we're not going to look at that in this video. So when atoms gain or lose electrons, they form ions. So like we're saying, ions can either be positively charged if they lose electrons, or they can be negatively charged if they gain electrons, because we've got to think that electrons have a negative charge. So if that atom is gaining an electron, it's going to make it overall more negative. If it's losing it, it's going to make it all overall net positive, because if you remember, the number of electrons is equal to the number of protons. Okay, and protons are positive, electrons are negative. So at the moment, they balance each other out. But when we start gaining and losing, that's when we get the charges on those ions. Okay, so if we think, then we'll take, for example, group 1. Okay, so group 1 here, it's got 1 electron on its outer shell. So therefore, it's going to lose that electron, making it have a positive ion. Okay, group 2, that's going to lose 2 electrons, making it have a positive overall charge, positive 2. Okay, group 3 will lose 3 electrons, making it positive 3. Group 4, however, doesn't form ions. Okay, group 5 is going to have -3. Okay, it's going to gain 3 electrons. Group 6 will gain 2 electrons, making it a -2 charge, and group 7 will gain 1 electron, making it a -1 charge. Now, ionic bonds always form between metals and non-metals. Okay, so groups 1 to 3 will form a positive ion, and they're the metals, whereas the non-metals over here, groups 5 to 7, tend to form a negative ion. Okay, so let's look at this in practice. So we've achieved those first 2 objectives there. So let's look at an example. So we've got here sodium. We can see that before sodium has reacted, when it's an atom, if you like, here, it's got 1 electron on its outer shell. Now the losing of that electron, okay, means that it gets a positive charge, and we draw them like this. Okay, so we can see that we'd write sodium plus, okay, so it's got a 2-8 structure. Okay, it's lost that 1 electron. Okay, so if we look at chlorine, we've got chlorine here has got a 2-8-7. Now, if we think about it, it's going to be easier for that chlorine to gain 1 electron than it is to lose 7. Okay, so it gets a 2-8-8 structure. Okay, which makes it have a negative charge. Okay, and you can see that what they've done to represent that is used a different symbol. So we refer to this as dot and cross. So the electron that's been gained here has been drawn as a cross. Okay, so you can see that it's come from elsewhere. Okay, so here what we've ended up with is sodium chloride. Okay, so sodium has lost that 1 electron that chlorine has gained. So chlorine, when it is an ion, we refer to as chloride. So here we go. If we look this side, we've got sodium chloride. Okay, this is where things get a little bit more confusing, if you like. So these charges need to be balanced, okay, to be able to have a structure, okay, they need to be balanced. Now, if, in this example here, sodium chloride is balanced, okay, 1 electron is donated, and therefore we've got a balanced compound at the end. However, this example is a little bit more confusing, okay, and a little bit more complicated. So if we think about calcium chloride, okay, chloride will lose 2 electrons, okay. Now we know that chlorine only needs to gain 1, okay, to give it a full outer shell. So therefore, if calcium's losing 2 electrons and chlorine needs to gain 1, we must have 2 chlorines present, okay, to be able to make it work and to be able to make those charges balanced. Okay, so that makes our formula here CaCl2. Okay, so that's when you look at balancing equations, okay, and you might look at it and think, this is totally baffling, I can't get my head around it. Well, if you think about it on this level, it makes a bit more sense that if we're losing these electrons, okay, so we're losing 2 electrons and chlorine's gaining, can only gain 1, then therefore we must have 2. if you're struggling with this, okay, I struggled with it, and it's absolutely fine to get your head around it. I always found it really useful when I was at school to draw them out, okay, and for the first couple of times that you do this, and it might be that it takes you 10 to 20 times, okay, it doesn't matter, but if you draw it out, then you get the idea of, okay, well, if one's being lost, then therefore we must only have one, or if two's being lost, then therefore we must have two, okay. Okay, so that's the third learning outcome. Okay, we've got some comprehension questions to have a go at now. So the first one, describe in terms of particle movement and energy how an element can change from a solid to a liquid. Okay, and the second one, describe the ways in which an atom can achieve a noble gas status having a full outer shell of electrons. Okay, you might want to pause the video here. Okay, so let's have a look at this one. So we can decipher that from that first question, they're actually asking us about a physical change. Okay, it's not a chemical change, it's only a physical, because we can see that they're referring to a solid to a liquid. Okay, so my answer that I've talked about here is that I firstly refer to energy. So when a substance is heated, its internal energy increases. Okay, we know that because we're referring to kinetic energy there. So when we heat something up, the particles get more kinetic energy. So therefore the movement of the particles increases, and this means that the bonds between the particles will break, and then that leads to a solid changing state to a liquid. Okay, so describe the ways in which the atoms can achieve a noble gas status, sorry, Siri's going mad, having a full outer shell of electrons. Okay, so atoms can achieve a noble gas status by either gaining electrons from another atom or losing electrons, resulting in ionic bonding. Okay, the atoms could also share electrons. Okay, but again, sharing refers to covalent bonds. Okay, now take your time on this and think really carefully what we've said about the charge on an electron and what charge they carry. Okay, so for each of the groups below, state whether the element will gain or lose electrons and what the charge on the newly formed ion will be. Okay, so we've got group 2, group 3, group 5, group 7. Okay, so group 2 will have +2, okay, because it's losing 2 electrons. Group 3 +3, losing 3 electrons. Group 5 -3, because it's gaining 3 electrons. Group 7 -1, because it's gaining those electrons. Okay. So diagrams, so draw diagrams to show the following ions. Okay, so lithium, magnesium, fluorine, and oxygen. Okay. Okay, so we've got the answers here. So we've got lithium, magnesium, fluoride, oxide. Okay, so oxygen will form an oxide ion, fluorine will form a fluoride ion. Okay. Okay. If I just show you here, they've gained 2 electrons there, but they haven't shown it as a dot and cross. Now you can see already the difference between these two. Okay, it's much clearer to see on this diagram. So I'd prefer it if you did it as a dot and cross, so to make it clear. Okay, the last question then for today. Calcium chloride has a formula of CaCl2. This is because calcium forms a +2 ion, but chloride is only -1, so therefore 2 is needed. Aluminium is in group 3 and oxygen is in group 2. State what ions they will form and give the formula of the compound formed. Okay, so here we go. So aluminium is 3+, meaning that 3 electrons have been lost. Okay, and the only way that we can make this balance is if oxygen here is going to be 2-, it's going to gain 2 electrons, okay, each time, so 2, 2, 2. So to be able to make that balance, we've got 6 electrons being lost, and therefore we need 6 to be gained. Okay, if we imagine that we only had one of the aluminiums, okay, we only had 3 electrons being gained.